Hello, everyone. Thanks for joining the MNIFY webinar. I will give the registrants a little bit time to join the webinar, so we will start in 1 or 2 minutes. I see that already quite a few attendees joined. Thanks for joining to this webinar. Okay, let's start. Again, hello from MNIFY. My name is Christian Henke. I'm the head of product from MNIFY. And today I'm going to talk about, let's say, one personal topic for me, which is security, IoT device security. I have been listening to many webinars and read many white papers around IoT device security, and the only things that I always was missing was, hey, no one is talking about what a cellular connectivity provider can actually do for security. So I often read about, how to change passwords, randomly generate them and stuff like this, which is for me common sense, but actually very little about what cellular connectivity providers like MNIFY can do to really secure your IoT devices. So this is what I'm going to talk about today, and there I'm going to dive into the top five cellular connectivity features. But before this, I want to also, let's say, give a little bit an MNIFY introduction just for people that are new to MNIFY, what MNIFY is about and what we're doing. And then I think about security, it's really relevant to understand what are the attacker types and their motivations to attack devices. Yeah. And then I'm going to go to the security features, and we will have a Q&A session at the end of the webinar. You can use the questions function on GoToWebinar. There you can just type in your question, and I will come back to that questions at the end of the webinar. Okay, I hope everyone can hear me loud and clear. If you have any technical issues, just also write a question. There's also someone else on the line and we'll be able to help you. Okay, then thank you, and let's start. So MNIFY, maybe for most of the people joining, MNIFY is known as a cellular connectivity provider that provides connectivity anywhere in the world. Yeah, so which is really relevant for the IoT space, where you ship your devices not only in a country, but you actually want to sell your devices globally, and you want to make use of many networks as possible so that you have better coverage. Yeah, so MNIFY provides SIM cards dedicated for IoT use cases that have access to 180 countries, 540 networks. So here in our home country, Germany, for example, we have access to the 3 networks. And our SIM card is not just a simple SIM card, it actually is programmable. So you have APIs and a portal to really steer and work with the SIM cards. So it's just not not just only about connectivity, but also about the management around the SIM card and the connectivity, the costs. And the thing that differentiates us is that we are actually where we believe where our customers are, or where we know where our customers are, and that's in the cloud. So many of our customers are in the big hyperscalers, AWS, Azure, or Google, and use these services. And we are actually have all our infrastructure also in the public cloud, are one of the very few that do so, and with that have nice integrations into these features on the bottom that make it easier for customers to integrate cellular connectivity when they're deployed in these clouds. Our customers are really, we're not a consumer IoT cellular connectivity provider, but really our customers are more in the B2B space or even B2B2B space, all across all verticals. Whatever you're doing, we probably have a similar use case already as one of our customers. And it's really about what I see as IoT is really about smart companies providing devices and applications to companies that provide services, and they even provide this as a service. Yeah? So a lot of the service model is here integrated, and cellular connectivity is usually a piece of it. If you sell devices with cellular connectivity included, then you have an additional value, not only because the devices are connected from the start, but also because you can, for example, create more security. So the topic we're going to talk about today. Okay, enough about Amnify, but let's start about, okay, what is, why is anyone attacking IoT, or what are the motivations? Yeah, and let's say from a structured approach, you have maybe these 4 groups. You have individuals, like there was always like attackers are script kiddies or anything. I don't believe that much anymore in script kiddies. It's still, there are people that do this for fame or because they want to be in the news, but more relevant are really like situations where individuals want to take revenge of their former employee or of organizations that harmed them, and that's where they then attack, try to breach the security of the system. Of course, then you have government and industry attacks, where basically you have espionage, and they just want to get intelligence about the person or about the data that the person has, or about the industry. Moral, religious, and political groups. So like this anonymous movement that have a specific purpose and want to showcase that. This was also the background, for example, from the Stuxnet attack, where an attacker group attacked the Iranian atomic program, for example. Yeah. And then this is what is, let's say, for most of my concern, is really criminal businesses. Yeah, so it becomes evident that people are not doing it just for fun or for intelligence, but really people are trying to make money out of attacking other devices, using the processing resources, using these devices to do attacks. And I think these criminal businesses, they have been very relevant in the IoT space, attacking different devices and taking control over these devices. And so to understand how these, why are they focusing on IoT devices? It's very very simple to explain. Yeah, so IoT devices, if you sell a lot of trackers or sell a lot of smart metering devices or smart cameras, then all these devices are usually configured the same. And once the once the attacker gets access to one device, he knows exactly also how to get into the other devices. So that makes it very attractive for attackers. They don't need to think about, okay, how do I get through multiple firewalls or anything. That's really, if I have access to one device, I can probably break into also alike devices. IoT is still, let's say, not very new, but let's say the security software on the devices is often not feasible or not as advanced as in normal PC or corporate environments. So that makes the devices more vulnerable because it's not really also not really visible what's happening. Yeah. And then you have users that in the regular use case where you have a laptop or your PC machine, you see that something is happening and you can at least do a reboot or run your virus program against it. On a IoT device which is out in the field, you don't see anything unless there's really you have extensive monitoring in place that shows you that there's something happening. And I think the fourth thing is really also lack of focus on security. Yeah? Whereas, let's say, companies that develop laptops or servers, machines, they are very focused because it has been a strong topic over decades, security. Whereas on IoT devices, usually companies, they come from a specific vertical and they are, the first thing that they think about is, I want to connect the device, get the data, and the second thought is about security. And this is also why, let's say in 2019, there has been a tremendous increase of IoT attacks. So some reports say 900% increase of IoT attacks, really infecting a lot of devices because there was a really lack of focus of these manufacturers with securing their devices. And this is where, I mean, we try to help, and this webinar is hopefully useful because I will give you examples on these most common attacks and how these are preventable with cellular connectivity. So maybe also to understand, how do cyber criminals actually make money with IoT devices? Yeah. So when I first purchased my first virus scanner, I was actually thinking that you know, the McAfees of the world, they were inventing viruses because they obviously made the most money out of it. But of course, there are other reasons. Yeah, and for these IoT devices, a lot of the attacks go that the attackers take control of the device, and then they sell denial of service attacks. So here, this shows a screenshot. They actually sell a denial of service attack. So you can purchase from this criminal website, I want to attack this website, please send a lot of traffic to this website so it goes down, or to the server and service. And you can do this on a monthly way, like you would currently buy software. Another very prominent use case is ransomware, which is also, let's say, widely known in the laptop or normal workstations, is where the attacker takes control of the device and then makes it unusable unless you pay a ransom, unless you pay money or Bitcoin, which cannot be tracked, where the payment goes, and then only the device will work again. Another interesting use case which some of these IoT malwares were using is cryptocurrency, or not currently, sorry for the spelling mistake, cryptocurrency mining. So obviously for cryptocurrency mining, you usually need quite a lot of processing power, and so criminals were trying to use IoT devices to do so to make money out of this. But actually, it's not really successful because usually these IoT devices have very low computing power, and the success here is not as big, but still something to watch out on the devices. So here I have three common IoT attacks that were relevant in the last 1 or 2 years. Maybe Stuxnet is a little bit earlier, but there's a large attack group of malware or vulnerabilities that the Mirai and its variants Chalubu and Lickerbot are using, and they all follow the same pattern. Yeah? So actually the attacker scans the public internet for IoT devices and tries to utilize remote access ports to log in. So over SSH or Telnet, just trying password combinations that are very common or unknown for the devices, and trying to log into the device. And once they logged into the device, they shut down everything that no one else can log into the device, and then they execute a denial of service attack onto a different victim. And this has actually brought down a lot of major services that were affected by these Mirai distributed denial of service attacks. And I highlighted here some of the, let's say, security vectors or attack surfaces which the Mirai botnet is using. So using public internet, remote access, and then executing a distributed denial of service attack to victims which actually the device should never send traffic to. And I will show later on how this can be prevented with cellular connectivity. The Stuxnet attack is, I talked about a little bit. It was the Iranian atomic program that was attacked with Stuxnet, and it actually utilizes exploits of Windows machines or on regular workstations, and then really tries, once it gets into this workstation, tries to look on the private network of that company if there are specific programmer logic controllers, these PLSCs from Siemens, in the same network, and then executing commands on this PLSC. And this actually has led to that the turbines in Iranian atomic facilities were running wild, and really caused a lot of trouble there. And here you see it's actually not that the attackers were directly attacking the devices, but were actually using vulnerabilities from just devices that were on the same network. And another attack is Lickerbot, which is very similar to Mirai. So it uses also the remote access and public internet and standard logins, but it's actually then making the devices unusable. So really bricking. And with that, you can imagine if your devices are with the customer and you cannot log in, you cannot do anything, there's really this is really loss in reputation and also, of course, revenue. So I think this sets the stage, just to give you some background, why security is relevant, what is currently happening for attacks. And now I want to go over to the top 5 cellular features to protect you from these attacks. And actually, these 5 cellular features are taken out of our security guide, which we have written, which really summarizes 25 plus best practices and cellular features to secure IoT devices and applications. You can download it for free on our website. under this link. I think we will also share this on our chat. So it really gives a checklist of the things that you can do, very understandable, and it's not really just only about changing passwords and making sure that that means security, but I wanted to focus on features that cellular connectivity providers are offering so that you can make your solution more secure with the onboard features of a provider and don't have to do as much on your side. So let's start. The first cellular connect, let's say, security feature I want to talk about is the secure remote access. Yeah, so in the Mirai attack, you've seen that this was one of the attack surfaces that the criminals, the cyber criminals, are using. And with cellular connectivity, actually you get a very nice way of getting a secure remote access. It's actually one of the reasons why several customers are choosing cellular connectivity, because with other solutions like Wi-Fi, let's say the setup is a lot more complicated than with cellular connectivity. And if you want to get secure remote access, for example, to get log files or to get data that's stored there or to execute commands, you have to be careful when choosing the connectivity provider. So usually you have two different, or actually 4 different versions of IP addresses that you can get. So there's private and public IP addresses that are available, where public IP addresses are not recommended because actually then your devices are on the public internet and an attacker could directly route traffic to the device. So here private IP addresses are recommended because with this, it's the devices are in a private subnet and you would not know, but the attacker does not know where to route traffic to these devices. And the second criteria is static and dynamic IP addresses. With static IP addresses, you have one IP address that identifies the SIM card and the device where you can directly connect to this device, whereas dynamic IP addresses means that the device would get an IP address, a different IP address every time it would create a data session. Whereas dynamic IP addresses seems to be more secure, the setup to get remote access to these devices is a lot more challenging because then you would need to make sure that you're actually not using the IP address, but for example, like a DNS name to resolve this to the device, and you need to have like a dynamic DNS service on the device, which is often not feasible. So our recommendation is to use static private IP addresses. And then with the static private IP addresses, you can log in from your laptop over, for example, OpenVPN to the device directly with authenticating with the mobile network with the cellular connectivity provider VPN gateway. So this is more secure because actually the authentication of the server and the device is done by certificates, and there's also private key encryption. Without this knowledge of the certificate and private key, the attacker cannot really get access to the device. And there's also an application token or a user password combination that is required to log into the devices. And this is one functionality, for example, that MD5 offers as a free service, because we really believe this is the right way to securely remotely access the devices and provides a lot of values for our existing customers. The second feature I want to talk about is closing the internet gap. Yeah, and let me explain what this means. What does the internet gap is? And one attack vector that is usually of concern is when data is transmitted over public internet. Yeah, and this picture shows that the device with the SIM card actually is secured within the mobile network. Yeah, so your device connects to the antenna next to you, and then the processing takes place at the cellular connectivity provider. And dependent on the, let's say, the address where your application resides, it actually then breaks out to the public internet. And from the cellular connectivity infrastructure to, let's say, to your cloud application, it's using public internet. And this security gap is, there are ways to close that. And there is, this is what I'm showing now. So traditionally, cellular connectivity providers are using private APNs with IPsec to really close this gap. So it's a very common approach. These private APNs are using, let's say, a public IP address on the cellular connectivity side, cellular connectivity provider side, and the your customer infrastructure side, and creating a secure tunnel. And through the secure tunnel, all the data is encrypted, and also you have data exchange. So you cannot only that the devices can say that to the infrastructure, but also from the infrastructure to the device. Usually this private APN setup is also with traditional operators bound to static IP addresses. So if you want to have static IP addresses, you need a private APN. Setup usually takes a couple of weeks to do, because the operator needs to set up DNS resolutions for this private APN, and needs to get the IPsec up. Yeah, then there are different quality levels, like how many redundant VPN connections do you have, and this is also somewhat costly to set this up, because the connectivity providers involved in setting this APN up. Now, what's possible if your infrastructure is in the cloud? You have cellular cloud platform providers like MNIFI that are able to give you intra-cloud connect. So actually, in the MNIFI case, our cellular connectivity infrastructure is already on Amazon, and we are already securing all the path up to Amazon. So there is no public internet anymore between the cellular, the infrastructure, and your application. And there is an intra-cloud connect, which is done by a service called Transit Gateway. And the nice thing about this service is it's really set up in minutes. It's a lot cheaper than IPsec and APNs. It is a complete cloud service model, so you can start, stop as you desire. And there's really nothing about public IPs involved, and you have the same and more benefits to the IPsec space. Okay, then I want to talk about the third feature, and that's the cellular data firewall. And coming back to the Mirai attack, or to, let's say, to standard IoT attacks, is when an attacker tries to, let's say, control the devices, there is obviously traffic going back and forth to the attacker. And then if the attacker executes a disputed denial of service attack on a victim, also data is sent to the victim. And actually with cellular connectivity providers, you have the possibility to configure a firewall directly in the mobile network. So you don't need to do this on the device, which is usually very resource constrained. And it doesn't help if you do it on your infrastructure, because the traffic never goes there. Yeah, so the only way to really do it is in the mobile network. and their APIs or just the portal exported, or you configure it with the cellular connectivity provider, that the data cannot be sent to anywhere else than your really true application. And if you want to think about it, it's actually, instead of having a SIM card to connect everywhere, you actually have one SIM card that connects just to your server. So you have your own SIM card, which is just purely usable for your use case. So actually, I have seen a couple of forum posts that were talking. I think I talked about this 2 webinars ago, where there were Lime scooters that had SIM cards in them, and people realized that they were able to use these SIM cards anywhere, and were like free riding basically on these SIM cards, and getting connectivity globally from the provider. So this is the way how you can stop it. Another, actually 2 features, but I thought I combined it because it's the same concept, is voice and SMS service firewall. So we just recently wrote a blog article about SMS attacks. So there has been an increase of SMS attacks in the end of 2019. 2 attacks, SIMjacker and whip attack. They both use a similar vulnerability. So usually you have on SIM cards different applets, the start browser and the wireless internet browser in this case. And these SIM applets, like every SIM card is like really a small computer processing environment. And these applets, they have different purposes. And these SIM applets can usually be configured, steered, controlled over SMS. Usually they check if the originator of the SMS is really the operator, so the cellular connectivity provider. But in this case, these SIM applets did not check this. And this made them vulnerable because attackers could send SMS to the SIM applets, and the SIM applets were able to do certain actions on the device. So they were able to, for example, send the location of that device. So they were able to track users. They were able to make SMS and make calls. So obviously quite of a concern, because at the end it's taking over of the device. And so these applets, they're not on the MD5 SIM cards, but it actually shows that the longer the SIM cards are in the field and the device, that there are more vulnerabilities coming up. And SMS and voice, they can be a vulnerability. So on the voice side, if you think about someone taking over the device with SMS, these SMS attacks, or with a Mirai attack, and then your SIM cards are still able to do voice calls, there's a very dominant attack pattern from criminals that use international revenue shared fraud. So what does it mean? Actually, they use these devices and do premium calls with these devices, and from these premium calls, they get a revenue share from the company that's providing these, and with that can make a lot of money. As you can see, voice fraud is still the top #1 issue for telecommunication service providers. It's really hard for them to track those. And usually what's happening is, if these devices make these premium calls, the operator would just charge the enterprise customer, and it will be then a long, fight who's at the end really paying for these premium calls. So the suggestions is here really to limit the services down to what is necessary for your service. Yeah, if your service does not need voice, which is the case in most IoT use cases, make sure you are turning off voice. So your cellular connectivity provider should be able to turn off voice. And also our suggestion is to use to deactivate external SMS, because it's also an open entry point where, let's say, anyone can send an SMS to the device if he knows the right number, and can, for example, execute an SMS attack like the SIMjacker and whip attack. Instead of using these external SMS, the connectivity providers are usually offering application to peer SMS. So this means you have the possibility to send SMS through a portal to the device and also receive them from the device, or you can even use an API or application to automate this sending of SMS. You can then, of course, also integrate this API into your application, so that you also have the possibility that your customers can send SMS to the device to do configuration. Then there's also SMS firewalls. If you want to make sure that your customers are not able to reach each other, then you can turn off internal SMS between your customers, or activate it if they should be able to send SMS, because that's the way how they configure. And you can also limit mobile terminating, so receiving SMS or originating SMS. So all these configurations, you should really look into what is your use case, and then limit the functionalities to really limit the attack vectors to for criminals. Okay, and this leads to the feature number 5. And the feature number 5, if you talk about security, there you always need to have some monitoring in place. So we as MNIFY have an extensive set of monitoring capabilities on every piece of our solution, and I trust that anyone who's really doing serious business is doing the same. Yeah, monitoring the service quality, but also have really all the data available to make sure that an abnormality is detected and can soon be resolved. Yeah, and in the, let's say in the IoT space, you have different sources of data. So you have the application data from the application that you develop, the device data, infrastructure data where your application is hosted, and you should also include connectivity data into your monitoring capabilities. You need this connectivity data because there are a lot of things that you don't see on the other sides. And with connectivity data, you get information about volume cost, of course, but you also get information about the network changes, if the device is online or not, if the device was able to properly authenticate in the network, or if there are roaming issues, and if maybe the device has reached its data limit, and is that the reason why it's not working. So we as MNIFY, we provide a real-time data streamer that delivers this connectivity data, and with that you can, let's say, enhance your existing monitoring also with connectivity data, and with that get a 360-degree view on the system. And it's not only about attacks, but usually what we see is that a lot of the things are user errors, and with having the right monitoring in place, you can quickly detect it before actually your customer is affected. These monitoring, of course, you want to have real-time data. So it's not that you get the information 3 or 4 times after your customer has an issue. And it really helps your service team to troubleshoot and troubleshoot customer issues, but also to detect attacks. Okay, with that, I've actually come already to the summary. And I truly believe that cellular connectivity is the right way to go if you want to increase the security of your devices. So compared to other connectivity methods, cellular connectivity has some benefits, like it is a separate network. Yeah, if you think about the Stuxnet attack, which was using a vulnerability of the Windows machine, if you put a SIM card in the device, actually your device is on a complete separate network. It is using the GSM security, and with that not reachable for anyone else than you. It prevents Mirai attacks. So as I was showing with the features, remote access, closing the gap, and the firewall, you can use cellular connectivity not only to get this remote secure access, but also to make it impossible, even if an attacker has taken control of the device by means of, for example, physically getting into the device, he would still not be able to make use of the device because the data is blocked, everything else than the legit data. You can get an own private network between all devices and applications. So everything is like in your lab. They are in a private network. They can communicate with private IP addresses. There's really no communication that sneaks out to anyone else. And with that, it's hidden in the private network. Another thing is really the central control of connectivity and also the central monitoring. If you think about Wi-Fi or other connectivity methods and you have multiple deployments, 10 or 20 customers where you deployed maybe your own Wi-Fi infrastructure, because you want to have a separate network there, you still have the issue that you won't need to get back all the data from the different deployments, all different setups. And with connectivity data, you have all the data already in a central place from your connectivity provider and can use this for central control or for anomaly detection. Okay, so these are top 5 highlights of cellular connectivity features that will secure your network. I hope it was useful. There is more 25 plus best practices on how to secure IoT devices. There's a really nice checklist in the guide where you can just check, okay, have I done this? Have I done this? Okay, maybe this is something to consider. Please check it out here on the download link. It's completely free. Okay, and with that, I'm at the end of my presentation. We would come to the Q&A section. Are there any questions? Let's see, there's just... Okay, I don't see any questions yet. While we maybe you think about questions, I would like to do a small poll. Yeah, so this is the third webinar that we've done around cellular connectivity, but actually we think that you're probably also interested in more information about when, around your IoT solution. Yeah, it's not only about cellular connectivity. So we would like to invite some industry leaders about several topics. And I wanted to check what would be your highest interest of topics that we should talk about. And there's a poll. Be really thankful if you would answer the question, and we will try to get really professionals in and have with them a talk about, for example, what type of batteries are most useful when developing an IoT device. Also, if you have maybe other topics that you're currently struggling with, you may also send this in the question panel. We would be happy to get those in. Okay, thank you for voting. Oh, I now see that there were actually quite a few questions. So let me take the chance to answer them. Top 2, closing the security gap. I showed with AWS. Yeah, this is currently what MNIFY supports. For Azure, we have redundant VPN integration. It's not the Secure Intercloud Connect yet, but it's on our roadmap to also deploy on Azure. But you can check out our cloud integration guides on MNIFY under resources, where there's also an Azure integration guide, which shows you how to use managed VPN services to set this up and close the security gap without private APIs. How secure is MNIFY solution? That's a difficult question to answer. Yeah, so there's multiple ways of answering this. So as a cellular connectivity provider, we use a lot of the security that is standardized by the GSMA. So we use all these features, functionalities that all the other operators have. And with that, we provide security. Then there's, of course, these security features that are presented. Some other operators are not offering it, some others are. I think we are really focused on security and have these extensive set of features available. So you can check out the functionalities. I think this is really what differentiates one cellular connectivity provider from the other, is what features do they additionally provide compared to the standards. Hi, is this guide include also information about security Wi-Fi or no? Yeah, so very good question. I mean, if you want to, if you think about Wi-Fi, then this guide will not be for you. There's a little bit maybe in, but not specifically for Wi-Fi. I really wanted to concentrate in this guide on cellular connectivity because all the other guides are very broad, different use cases. And on this guide, you have really insights on what is possible when using cellular connectivity. What if I want to use some end-to-end encryption for my IoT? I guess it's totally code. If I want to use some, sorry, I cannot read the full. I guess it's totally transparent to you. No, okay. So end-to-end encryption is of course still viable. We as a connectivity provider and operator cannot see any payload. Yeah, we cannot look into the data. That's not possible. But of course, I can understand if customers are doing end-to-end encryption, and actually this is also what is mandated by some of the cloud platform services. Yeah, if you want to integrate an AWS IoT or Azure IoT, you need to use certificates. Yeah, we have integration guides for these services as well. But if you use just virtual machines, application servers running in the cloud, the Secure Intercloud Connect is the way to go. And it's really maybe an add-on or may even replace end-to-end encryption. How do you secure inter-network communications, for example, between different subsystems from different providers that may benefit from using each other's data? I'm not sure if I have something in mind which if this is about roaming and carrier services, but I think this goes too far. Maybe we can have a chat afterwards. You can reach me on LinkedIn, christianhenke.com, or just my email address, christianhenke@mnify.com. Just shoot me an email when we can have an offline discussion about that. I'm not sure if I completely understand the question. Hi, sir. Is it possible to set limitation and range of IPs, I guess, that our device connected to? So with MNIFY, this is possible if you have a certain amount of devices, but you would need to open a service. On our roadmap, it is planned to make this also available as an API, so that you can configure this directly in the portal. Is Cellular infrastructure deployed in public cloud infrastructure? Can you provide more details? Can you provide more details what is deployed? Okay, so there's actually, our website has a lot of information around this, but give me, let's say, from a high level point of view. MNIFY was launched, or the company was founded in 2014, where Amazon was just beginning. And the founders had a real, let's say, good nose or intuition about what is happening in the IoT space. So, and they saw, let's say, with using Amazon as a cloud cellular infrastructure, there are different benefits. And I showed this slide in the beginning, where you have, let's say, a high available infrastructure, but also a distributed infrastructure. All our infrastructure, HLR, HSS, PGW, all the let's say all the nodes that a typical core network has, is deployed in a public cloud infrastructure. And I'm happy to have discussion if someone thinks this is not the most secure way. I think it is the one, because actually the people in Amazon or in Azure, they do secure their infrastructure since 30 years. They have thousands of people working on it. This is way more secure than if someone else would do it in a on-prem solution. That's my take. One thing, of course, is privacy concerns, that data goes to the public cloud. But actually here, this deployment model is also helpful, because we have, with a global distributed infrastructure, we actually leave the data where it originates from. Yeah? So European devices that are in Europe can leave their data in Europe. So there we have a breakout region. Data that is in US stays in US, and data that's in, let's say, Asia Pacific stays in Asia Pacific. So we use this regional breakout. Happy to have a discussion also. If you want to have a follow-up, just shoot me an email. Okay, so thanks for answering the poll. I see that 75% voted. That's a good attendance. And top runners are state-of-art of sensors, international certifications, type of batteries. So we will, and also ways to locate devices more precisely. So I think with that, we also have, let's say, 4 topics for the next webinars that we are planning right now. And we will update you and invite you to the next webinar. Okay, thanks for joining. I hope this was helpful. As said, you can connect on LinkedIn or email if you have any other questions. Thank you.